All right, we're going to see if we can do this in one shot here. There's quite a bit going on in this one, so we're going to jump right in. We are solving rational functions. This first type of rational functions, a variable only shows up once, so we can see that that's just a transformation of a parent function. So we should be able to use arrow diagrams to help us out. Once we've got the arrow diagram built for this first one, that'll help us for the other one. So let's take a look at this first one, and we'll build the arrow diagram. Starts with an x. We multiply by 2, subtract 1. We need to flip that over to get it into the denominator. Multiply by 9, do a sign change, and then add 3 on. And since I'm going to be using this arrow diagram again, I'm going to group this stuff all together, make sure I have access to that a little bit later. On this first one, we just want it to equal 0, which means we're going to load a 0 on this end. Our arrow's coming back this direction. This one would be a subtracting 3. It's another sign change. Division by 9. A flip over, add 1, and divide by 2. So if I start with the 0 and followed it there, I'll do that in green here. So there's my 0. Subtract 3, I'm at -3. Sign change, it's a 3. 3 divided by 9 is a third. Flip that over, it's a 3. Add 1, it's a 4. 4 divided by 2 is a 2. And so x equals 2 is the solution to that first one. We should probably note along the way here, we do have something in the denominator there, so we can specify that for the domain that 2x minus 1 cannot equal 0, which means 2x can't equal 1, and x cannot equal 1/2. 2 is not 1/2, so it's a perfectly good solution for that first one. On the next one, we want to make it equal 6, so we'll start here with a 6 instead of a 0. 6 minus 3 is 3. Change the sign. That is a -3. Divide by 9, that's a -1/3. Flip it over, we have a -3. -3 plus 1 is -2, and -2 divided by 2 is -1. So x equals -1 should be our solution to this one. Over here, this first one that I did in green here again, this gave us an x equals 2 as a solution. The last one is an inequality, and our inequalities are a little bit easier to see if we are actually graphing them. And so I'm going to make a copy of this arrow diagram and bring it down here for this so that we can put the graphical parts of things in there. Okay, that next problem showing up here a little bit. We'll get that out of the way. And so to graph again, we start at the parent function, which is right here. And we know on this parent function that our end behavior is when we put a negative infinity in, it heads towards 0. When we put a -1 in, we get a -1 out. 0 creates a vertical asymptote. 1 in gives us a 1 out. And an infinity out on the right-hand side of our end behavior is heading towards 0. So if we then multiply all these things by 9, 9 times 0 is still 0. Got a -9 there, still a vertical asymptote, +9 and 0. Sign changes on all of these, 0, 9, still a vertical asymptote, -9 and 0. And if we add 3 to all of those, we've got a 3, we've got a 12. Moving a vertical asymptote up and down doesn't change what it is. We've got a -6 and a 3 right there. On our other side over here, we need to add 1 there and divide by 2. So this will continue to be -infinity. I'll squeeze that in there. -1 plus 1 is 0. 0 plus 1 is 1, 1 plus 1 is 2, infinity plus 1 is infinity. And when I divide by 2, I still have a negative infinity and a 0, and now a 1/2, and a 1, and an infinity there. So, still describing my in behavior on those, I can then create a graph here, and the points of interest on the graph, I have a vertical asymptote. Here comes, I can track that back over there, and it says that occurs at x equals 1/2. So if I mark these as 1, 2, and 3, like that, then 1/2, a vertical asymptote would occur right in there. My in behavior is a horizontal asymptote. I can see that. I can track from my in behavior in this direction to see that I have a horizontal asymptote at 3. So if we mark that there. And then if I can pin down one point in here, then I'll know where things go. I know that the point 1, -6 is on this. That would work. I also have points from up above that I could make use of, but won't always have those. 2, 3, 4, 5, 6. So 1, -6 is here. That does seem to indicate that this graph is going to come up this way. I am going to need to know where it crosses the axis, and I did find that up above here on this line that happened at 2. So it's going to cross there, coming up, crossing at 2, heading out that direction, which means this other piece must be out here. It won't have anything to do with the x-axis. And since our problem, see if I can grab that and bring it down here, okay, was to know when this is greater than or equal to 0. Well, I see this whole part of the graph is above the x-axis, and starting here and out here, that part is above the x-axis, and the input values that will create this start at my vertical asymptote, not at that point, and head this direction for all of those values. I get x's that are above the x-axis, and out here, starting here and going that direction. So I would write my answer as all the x's from -infinity to 1/2, together with the one starting at 2 and going to infinity out that direction. And that should be my solution to the last problem. Let's jump here to the next kind, which may be slightly more complicated. We'll take a look at these and move some of this other stuff down, give myself a little bit extra room. Okay. So our process on this one is going to be going straight to a graph. It's an inequality here. If it just said equals 0, I'd make the numerator 0, and I get 3 and 4, or 3 and -4 as answers. So I can spot those as my zeros right away. Those are at 3 and -4. I can see that I have vertical asymptotes at 0 and at -2. Not sure why I went with the parentheses there. And something special going on at that -2 because of the multiplicity on there. I could analyze my in behavior on this graph to know where to get things going. I'm going to end up with an x squared in the numerator and an x cubed in the denominator, which reduces to a 1 over x, and that looks like this, so it will have the same in behavior going on the graph there. So I'll make my axis. On my x's, I need to go 1, 2, 3, I'll go out to 4, and to -4 this way. My zeros, going to cross the x-axis there, and back here I have vertical asymptotes at 0 and at -2. Something odd going on that one. And it tells me my graph is going to start out here below the x-axis but close to it. So it must come in, dip away a little bit, come up through there, do the vertical asymptote thing. It is an even multiplicity, so it's my volcano style vertical asymptote. No place to cross, so it has to turn and go back up that direction. It's a regular asymptote, so it will be on the bottom here, come up, it has some place to cross, it crosses and then settles back down towards the x-axis that direction. We wanted to know where this was greater than or equal to 0. So the parts of the graph that I see above the x-axis or on it start here and up this way. This whole piece and then this part out there. The parts of the x-axis then are from here to here, from there to there, and then from there on out that direction. So it's in 3 pieces, and my solution should be from -4 to -2. Should square bracket that -4 because that one does give me a 0 and it's a greater than or equal to. Need to go from -2 to 0, and from square bracket 3 on out to infinity. That should be my solution for that one. This one's going to take a little bit more work. We'll see if we can knock this off here. So first thing I need to do is find a common denominator. That common denominator is going to be x plus 2 and x plus 4. So I'm going to have to multiply x plus 4 over x plus 4 times the 3x over x plus 2 minus, this one needs an x plus 2 times 2 over x plus 4, and this is going to need both of them, the x plus 2 and the x plus 4 over x plus 2, x plus 4. Okay? And now that my denominators are all the same, I can actually ignore the denominators, okay? Or I could multiply by those. Before I get rid of them, I should note in my domain that x cannot equal -2 or -4. So if I come up with either of those answers, I'll know that those don't actually work. So distributing up here, and we get a 3x squared plus 12x. We're going to get a minus 2x, and that minus is also going to hit the 4 on there, greater than or equal to 7 times x squared plus 6x plus 8. Combining everything together then, I'll rewrite here a little bit. 3x squared plus 12x, 3x squared plus 10x, I can simplify that part. Minus 4 is greater than or equal to 7x squared plus 42x plus 56. Getting everything on one side, I get a -4x squared minus 32x minus 60 is greater than or equal to 0, which I can factor a -4 out of. So I'll do that. X squared plus 8x plus 15 greater than or equal to 0. If I divide by the -4, I get x squared plus 8x plus 15 is less than or equal to 0. This factors into an x plus 3 and an x plus 5 less than or equal to 0. I'm going to do this a little bit different. I'm going to put a number line down and point out that at -3 and at -5, I have zeros on this, and I'm going to test the 3 different parts of the axis here to see which ones have good answers and which ones don't. So I'll use a -6 there, a -4 there, and I'll grab a 0 from there. If I test the -6 in this, I'm going to get negative 6 plus 3 times negative 6 plus 5. And I want to know, is that less than or equal to 0? That gives me a negative 3 times a, negative 3 times a negative 1, which is a 3. Is 3 less than or equal to 0? No, it's not. Okay, so I don't have any answers over there where the negative 6 is. If I test the negative 4, I'm going to negative 4 plus 3 times negative 4 plus 5. I want to know, is that less than or equal to 0? This is going to give me a negative 1 times a positive 1. So is negative 1 less than or equal to 0? And the answer is yes. So all of those answers from here to here are good answers. And if I test the 0, I'm going to do that in the quadratic form that I had up here and do 0 squared plus 8 times 0 plus 15 less than or equal to 0. And that just is asking, is 15 less than or equal to 0? And the answer there is no, so those aren't any good. And my solutions then to the problem are all the points from negative 5 to negative 3, including negative 5 and negative 3. Let me check with my domain. Negative 2 and negative 4 aren't any good, so I actually have to get rid of the negative 4 and go from negative 5 to negative 4, union with negative 4 to negative 3. And this one, previously stated as my right answer, is not. But this one is.